Hello. In this video, we're going to continue learning about ways to arrange things, but we're going to look at different restrictions when we have some more information about how the arrangement has to take place. So for example, how many different ways can 3 girls, Alice, Betty, and Carol, and 2 boys, David and Eric, be arranged in a row if the boys and girls must alternate? Now, if they were going to be arranged in a row and there was no conditions, no restrictions, we would just have 5 things being arranged, or 5 people, and we would do 5 factorial. You can even notice I've given them nice names, A, B, C, D, and E. So it would be the way of arranging the letters A, B, C, D, E, 5, 4, 3, 2, 1, 5 factorial, easy peasy. But now we have this condition, the girls and the boys must alternate. So again, whenever we have a new situation, it's nice to try to write out the options and go back to the drawing board. Well, we could have A, B, C, and then between them, we could have David and Eric. Or we could have A, B, C, and then we could have Eric and David. This allows the boys and the girls to alternate. We have girl, boy, girl, boy, girl, and we have 2 different options here. But I think there's more than this, so I'd encourage you to pause the video and see if you can write out all the different options. All right, assuming you gave it a try, you should come up with A, C, B. We have D, E, and then A, C, B. And then we switch the E and the D. This looks like all the ones that start with A. But of course, we could start with B. So we could have B, A, C. And then we'll make space here for the 2 different options where it's either D, E or E, D. Then we could start with B but have C next. And again, we have to make space for the 2 options, either D, E or E, D. I think that's all the ones that start with B. So then let's look at all the ones that start with C. We could have C, A, B. 2 options there because we could have D, E or E, D. And then C, B, A, C, B, A. And again, we have either D, E or E, D. So I think that's all of them, because if we're going to alternate, because there's more girls than boys, we couldn't start with a boy. If we started with David and then went Carol and then went Eric and then went Betty, we'd have to end with Alice, and Betty and Alice would be side by side, so that doesn't work. We have to start with the girl, and so we either start with Alice or we start with Betty or we start with Carol. And then we work it out, and each one of these has 4, so 4 plus 4 plus 4 gives a total of 12. Okay. So we know the answer is 12. How do we get this with a formula? Well, again, we're trying to use the blank method. This seems like a good idea. And so normally we would go 5, 4, 3, 2, 1. But I don't actually think there are 5 options for that first seat, because we have to start with a girl. So for the first seat, we can only have A, B, or C. So you only actually have 3 options for the first seat. Now the next seat has to be one of the boys, so that's going to be either D or E. So there's only 2 options for the second seat. Now the next one has to be a girl, and we've used up one of the girls. So again, if you think about it, this is going to be a girl, then a boy, then a girl, then a boy, then a girl. So we're going to have 3, 2, then 2 girls, then only 1 boy, because we used one of the boys back here, so there's only 1 left here. And then finally ending with our last girl. 3 times 2 times 2 times 1 times 1. That's going to give us, hey, 12. Nice job. Our formula gives us the same answer as counting them all out. And so this seems like we can just use the blank method. We don't really have to do anything else. I mean, we do have to be aware when we're using the blank method of what specific number goes where, because this has to be a girl and this has to be a boy, so this starts off with 3 and starts off with 2. But other than that, there's no real modifications we have to make to the blank method. It seems to work pretty good. Let's go ahead and try it, but this time with cats and dogs. So you've got 5 cats and 4 dogs. We want to arrange them in a row so the cats and dogs alternate. Go ahead and pause the video and give it a try. All right, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 animals. It's going to have to go cat, dog, cat, dog, cat, dog, cat, dog, cat, because there's more cats than dogs, so the cats have to start. And then we've got 5 cats, 4 dogs. Now we count down. Really, we could put the cats all first. 5 cats, 4 cats, 3 cats, 2 cats, 1 cat. Then we place the dogs. 4 dogs, 3 dogs, 2 dogs, 1 dog. And we multiply all the numbers in our blanks. 5 times 4 times 4 times 3 times 3 times 2 times 2 times 1 gives us a total of 2,880. All right, that seems pretty good. Let's try another example. So we have 2 cats and 2 dogs arranged in a row. How many ways if the cats and dogs must alternate? So pause the video and give it a try. All right, so we have 4 animals. So let's start with the cat first. Cat, then dog, then cat, then dog. 2 cats, then 1 cat, 2 dogs, then 1 dog. Multiply everything and we get 4. But this actually is not the correct answer. Let me go ahead and give the cats some names, and I'm going to show you why. Let's say the cats are named Alice and Betty. And let's say the dogs are named Carl and maybe Doug. All right. So we've got our cats and dogs. Maybe these aren't the best cat and dog names, but we're going to go with it. So we got Alice and Betty and Carl and Doug, and we're going to go ahead and see the different options. Well, we've got to have cat, then dog, then cat, then dog, or I guess we could switch the dogs around here. Then we could switch the cats around, so the cats go there. Dogs go there. Cats go there, dogs go there. I'm not sure the letters work good. We almost should have called them cat 1, cat 2, dog 1, dog 2. Yeah, this is getting confusing. Sometimes the way we write it doesn't always work great for the letters. So let's go ahead and restart it. Let's call it cat 1, cat 2, dog 1, dog 2. I know these are even worse names for the cats and dogs, but it's going to help our organization. So we have cat 1, cat 2, dog 1, dog 2. And then we'll switch the dogs around. Sometimes when you're writing it out, it's important that you get a good organization, a good lettering, a good naming, just so it makes sense, because we're trying to ensure that we cover every single option, and we don't want to miss any, we don't want to double count any. So you got to be a little flexible with how you name things. So here we go. We got cat 1, cat 2, dog 1, dog 2. We switch the dogs, we switch the cats, we switch the dogs. Okay, so here's our 4 options, just like we had with our formula. But because the cats and dogs could alternate, we also have the idea that the dogs could start first. We could have dog 1, dog 2, and we could have cats in the middle. Cat 1, cat 2. Switch the cats around. Dog 1, dog 2. Then we could start with dog 2 and have dog 1, dog 2, dog 1, cat 1, cat 2, or cat 2, cat 1. So there's actually going to be a total of 8. There's 8 total ways we could do this. We only came up with 4. This isn't good. How do we go from 4 to 8? I mean, sure, you could times by 2, but just that doesn't make any sense. The formula needs to have some idea, some sense to it. And the real problem here is that we assumed we could start with a cat. But we realized we could also start with a dog and it would still alternate because we have the same number of cats and dogs. So the cats don't have to be first. Maybe you love dogs, so the dogs can be first. How do we include this in our blank method? One way to do it is to draw another set of blanks and to do another option. Maybe where the dogs go first and then the cats, then the dogs and the cats. 2 dogs, 2 cats, 1 dog, 1 cat. Multiply them out. And that gives you another 4. So this is the case here with the cat starting, and this is the case with the dog starting. Now, these two cases are kind of like two different problems. And so when you have two cases, two different sets of blanks, you don't actually multiply these numbers because 4 times 4 would give you 16. And there's no way the answer is 16. We know the answer is 8. When you have two cases, what you actually have to do with the numbers is you have to add them. 4 plus 4, which gives us a total of 8. And this is the big insight. If you have different cases, like the case where the cat starts or the case where the dog starts, you do each case separately, doing the blank method and your logic and everything else, but then you add between the cases. Let's try this with another example. So we have 4 girls and 4 boys, and we want to arrange them in a row so the girls and boys must alternate. Pause the video and give this a try. So for this question, we have two cases. We have the first case with the girls starting. Then we're going to have the case where the boys start. So we have 8 people, so we draw 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. And we know it's going to go girl, boy, girl, boy, girl, boy, girl, boy. 4, 3, 2, 1 girls. 4, 3, 2, 1 boys. Everything gets multiplied, and that's going to give us, let me take a look here, 576. Then we do the case with the boys starting. 1, 2, 3, 4, 5, 6, 7, 8 blanks. Boy, girl, boy, girl, boy, girl, boy, girl. 4, 3, 2, 1 boys. 4, 3, 2, 1 girls. Multiply everything together. Another 576. Add them both up, and we get a total of 1152. 1152. Okay, now this question can be extended to do really interesting ideas. For example, how many words from the letters A, B, C, D, E, F that are 6 letters long, or 5 letters long, or 4 letters long? How many words can you make from that? Well, now you say, oh, in this situation, we have 3 cases. We have the case where you have a 6-letter word, or you have the case where you have a 5-letter word, or you have the case where you have a 4-letter word. Now, the nice thing here is I've tried to highlight it for you. The word or is keying us in that we have different cases. Just like before, you could start with girls or boys. You can hear the word or in the English sentence, girls or boys. It tends to indicate that we have different cases to consider. So here we have 6 letters long or 5 letters long or 4 letters. Each is its own situation. So for a 6-letter word, we draw 6 blanks. A 5-letter word, we draw 5 blanks. A 4-letter word, we draw 4 blanks. Now we'll start with the easiest one, the 6-letter word. We have 6 options for the first, 5, 4, 3, 2, 1. And then we simply multiply all these numbers together. That's going to be 6 factorial. And if you've been paying attention, you might have memorized this one. It's going to be 720. For 5-letter word, we still have 6 options for the first letter. But then we count down 6, 5, 4, 3, 2, and we end up at the 2. Because we don't use all the letters when we make a 5-letter word. We have 6 letters available to us, and one of them doesn't get used. Okay? Well, this happens to multiply to 720 again. But with a 4-letter word, you have 6 letters to start, then 5 letters, then 4 letters, then 3 letters. Now, 2 of the letters don't get used because you have only 4 blanks of the total of 6 that you could have. But again, you just follow the regular directions, right? You have 6 letters to start with, so when you're looking at that first blank in that 4-letter word, you put a 6. 6 times 5 times 4 times 3 is going to give us 360. And we now have to add these cases. 720, 720, and 360 gives a total of 1800. How many words with at most 3 letters can be made from the letters A, B, C, D, E, and F? Now I'd encourage you to pause the video and give this a try. See what you come up with. All right, that word at most might be giving you a hard time. Let me try to explain that for you. at most 3 letters means that you could have, well, you could have 1 letter, you could have 2 letters, or you could have 3 letters. But 4 is not at most 3. 4 would be definitely out of bounds. But 3 is at most 3. 2 is at most 3. 1 is at most 3. It's like if somebody said you could have at most 3 cookies for dessert. Well, you could have 1 cookie or 2 cookies or 3 cookies. So these are our 3 options. 1 letter or 2 letters or 3 letters. These are our 3 cases. And so we didn't use the word or, we used the word at most. But kind of baked into the statement, at most 3 letters, is the idea that you could have 1 or 2 or 3. All right, go ahead and pause the video now and see if you can come up with the answer. Okay, so you've got your 3 cases. Case with 1 letter, case with 2 letters, and case with 3 letters. So 1 letter, we'll draw 1 blank. 2 letters, we'll draw 2 blanks. 3 letters, we'll draw 3 blanks. You have 6 letters to choose from, so there's just 6. And 6 times, well, there's nothing at times, so you just get 6. This kind of makes sense, right? The 1-letter words are either A or B or C or D or E. We can visualize all 6 of those options, but of course the formula is faster. For 2-letter words, it's 6 times 5. That's going to be 30. For 3 letters, it's 6 times 5 times 4. So 6 times 5 times 4, which gives you 120. Now we add between the cases, and that gives us 156 different words that can be made with at most 3 letters. All right, let's go ahead and take some notes on this. So we were looking at cases today, and in particular, it's nice to look at cases that have sometimes the word at most, at least. So what do? Well, the general rule is whenever you have casework, okay, cases get added. That's the key idea. So you have case 1 or case 2 or case 3, whatever your cases are. And so you get some answer here, you get some answer here, you get some answer here, and you have to add these up to get your total. So let's look at an example. How many words that have 1 or 2 letters can you make from the letters A, B, C, D, and E? Go ahead and pause the video and give that a try. Okay, so we've got 2 cases. We could do the case with 1 letter or the case with 2 letters. If it's got 1 letter, we draw 1 blank. 2 letters, we draw 2 blanks. Now, because in this situation we have 5 letters to choose from, this would be 5. That equals 5. This would be 5 and then 4. 5 times 4 is 20. Adds up to a total of 25. Now, with an amount like that, we almost could write them all out. So if you wanted, for extra practice writing things out, you could go ahead and check it. See if you can find out all different 25 words that either have 1 letter or 2 letters from the letters A, B, C, D, and E. You might find it fun and relaxing just to write out all the combinations, but of course you don't have to. The idea here is to move beyond writing them all out and eventually develop these formulas. Now for some extra practice, you can look at worksheet 4 and 4.5. And you can definitely write down one of those examples. Pick one, maybe an easy one, maybe a hard one, and go ahead and add it here in your notes just so you have another example to look at. Then you can write down any things to remember. So one thing to remember might be that if you have at most 4 cookies, that means you could have 1 or 2 or 3 or 4. If somebody says you have to have at least 3 peppers, and let's say there are 7 peppers to eat, Man, this would be a lot of peppers. If you have to eat at least 3 peppers for dinner, and there's 7 peppers in front of you, you have to eat 3 or 4 or 5 or 6 or 7. Maybe we're not eating peppers, maybe we're looking at letters in a word, but same idea. These words at least and at most, they do indicate some kind of casework, and you have to use a little bit of logic to figure out what kind of cases you're looking at. All right, hopefully you enjoyed this video, and as always, thanks for watching.